Hey guys, so what we're going to go through now, this is just in the packet on page 9. It's just another example of a problem where we are classifying a triangle based on its side lengths and angles. This time we're just doing it from vertices instead of from a graph. The approach is not drastically different, so a lot of you guys can probably figure out how to do this on your own, but since I couldn't be there for class today, I just wanted to make sure that I had somewhere you guys could look to figure this out if you needed help with it. So we still want to know all the side lengths because I want to know if there are any congruent sides or how many pairs of congruent sides there are. Now, when we do this on a grid, it is usually fastest to just use the Pythagorean theorem. When we don't have a grid, I can't count the side lengths per se the same way I can on a grid. I can find them using subtraction, right? So if I subtract the two x values, subtract the two y values, it tells me the lengths of what would be the legs of the right triangle that you would normally draw on the grid. This is us just using the distance formula, which, as we've talked about before, is the same thing as the Pythagorean theorem. It's the same exact math. It's just that we are using subtraction in order to find the side lengths of those triangles. So, as a reminder, right, we have our distance formula, the square root of x2 minus x1 squared plus y2 minus y1 squared. And again, since this has come up before, no, it doesn't really matter whether you do x2 minus x1 versus if you had x1 minus x2 and y1 minus y2, since you're arbitrarily choosing which point to call point number 1 and which point to call point number 2. So when I go to try to find the side lengths, I still want to make sure I'm labeling very clearly. It's actually, I think, even more important here because there's not any visual to go by. So I want to make sure that I'm very clearly saying, okay, I'm going to start by finding the length of AB. And I know I need to find AB, BC, and AC, but I'm just going to start with one. And when I'm finding the length of AB, I'm just going to use that distance formula with the coordinates from point A and point B. So when I do this, I'm going to plug in my two x values. So I can take -5 and subtract -9. Right? And if I subtract a negative, that would be the same as adding, right? And then square it. And then I'm going to add the y value of -3 minus +3 and square it. When it comes to evaluating this, because there were some mistakes on the last graded warm-up that I handed back yesterday, still with simplifying this from here or evaluating it from here. So just be really careful in terms of signs, in terms of what you are squaring. So I have the square root of what comes out to 4 squared plus -6 squared. Now notice that that -6 is in parentheses because the entire -6 is being squared, meaning -6 times -6. That is so important because if those parentheses are not there, it means -6 squared. So a negative multiplied by 6 squared, which would give you a different answer because it would come out negative. So be very careful when you are squaring negatives, it will come out as a positive. And so this would leave us with the square root of 16 plus 36, or in other words, the square root of 52. And I'm just going to leave my answer in exact radical form, right? I can compare whether the sides are equal or not without evaluating that any further. So we're just leaving it like that. What I want you guys to do now, if you haven't yet, go ahead and find the lengths of the other two sides, pause the video, and then you can come back to the video in order to check your work. Okay, so to check our work for BC, I'm going to do the same exact thing, but again, this time I'm plugging in the coordinates from C and B. So I would take -2 minus -5 squared plus 4 minus -3 squared evaluates to 3 squared plus 7 squared, which comes out to root 58. Okay, So far we have found two side lengths. They are different from each other. So I already know it's not an equilateral triangle. Let me find the last side length, AC, in order to see whether it is whether it is isosceles or scalene. So using the coordinates from A and C, -2 minus -9 squared plus 4 minus 3 squared gives me 7 squared plus 1 squared, or in other words, root 50. Okay, so then I'm comparing all three side lengths, root 52, root 58, root 50. All of those are different lengths, and so I know that this is a scalene triangle because a scalene triangle is a triangle with three different side lengths. Okay. Now remember, I'm not done classifying just because I classified based on side length. I also want to classify based on angle. So we're not going to necessarily go through and determine whether it's acute or obtuse, but I do want to know whether this is a right triangle or not a right triangle. And as a reminder from yesterday, we can do that by using slope to determine whether any pair of sides are perpendicular. So I'm going to, again, clearly label my slope calculation for each one of the sides. So first I'll find the slope of AB. And again, when we are on a grid, we usually think about this as rise over run, fastest way to do it. When we're not on the grid, it's still rise over run, but we can do a subtraction to figure out what is the rise, what is the run. So if I subtract the two y values, that gives me the rise. When I subtract the two x values, that gives me the run. Now, we usually view this as y2 minus y1 over x2 minus x1. Again, technically, I could switch the place of the 1 and the 2 there. It doesn't really make a difference because you're arbitrarily picking, I want this to be 0.1, I want this to be 0.2. However, it is important that whatever point you use for this value, you also need to use for this value, right? My x2 and y2 do need to come from the same point. My y1 and my x1 need to come from the same point, because if not, you're going to end up with the wrong sign of your slope in the end. So coming down here to find the slope, I'm just going to use b as 0.2 and a as 0.1. So I can do y2 minus y1. And make sure you're remembering to do y in the numerator because the rise, right, would be with y. And then we would have -5 minus -9 in the denominator, giving us -6 over 4. And again, we should just always, as best practice, go ahead and simplify. So I'm going to simplify that to -3/2. Okay. And now what I want you guys to do, again, if you haven't yet, go ahead and find the slope of BC and the slope of AC. You could pause the video and come back to check for the answer. Okay. So again, I'm going to do y2 minus y1, but this time I'm using points C and B. So y2 minus y1, right, minus -3, x2 minus x1, minus a negative, again, being an addition. And that gives me 7/3. There is no number other than 1 that 7 and 3 are both divisible by, so there's no way to simplify that. Already done. And then my last slope would be the slope of AC. So again, y2 minus y1 over x2 minus x1 gives me 1/7. Okay. So when I'm looking at these slopes, I need to then compare them. I want to see if any of them are opposite reciprocals of each other, because if any two are opposite reciprocals, that means I have one right angle. When I'm looking at them, none of them seem to be opposite reciprocals. And because of that, I know that this is not a right triangle. So the full classification for this, based on side and angle, would be that it's a scalene triangle and it is not a right triangle.